Well, hi, everybody, and welcome to my workshop here in Daleville, Virginia, right outside of Roanoke. What I want to do on this module is just give you a basic feel for what is volume. What's volume all about? That is a property that you're learning about in thermodynamics class, and just want to help you get a physical feel for what is volume, and also have some slides about what is specific volume and what is density. A little bit like a crash course on that. But I want to welcome you to these videos if this is the first video you're watching. Most of these videos are sort of just on desktop, but this is one I wanted to give a physical some show and tell type things too. So let's get started with a little bit of a PowerPoint, and then we'll go to show and tell. And so I'm sort of winging it, so bear with me and let's give it a try. Bear with me a second. Normally I'm a little faster, but okay, so this is the module for the property volume. And what I'm going to do is I'm not going to drag you through all of these slides, but I'm going to try to chase you to clicking on the link of the static PowerPoint slides. And that way you can browse at your leisure all of the gory details in slides that you may or may not be interested in. So anyway, included at no extra cost, specific volume and density. So let's see where we're going from here. So the objective is to give you an understanding of the difference between volume, specific volume, and density. I want to show how these properties are related to one another, and also looking at units. Units are going to be so important for you in this thermodynamics class and beyond. Okay, so I do see I've got my next slide as my prompt to go live. And I am showing here a set of conversion factors, and this is a little block associated with volume. And so I do want to encourage you, let's say tonight, to go and find, it's one page somewhere in your textbook, whether you have a paper textbook or an electronic textbook, you must be able to find this one page that contains conversion factors and other valuable things. And so you need to either link it or get a copy of it, or be able to get to that one page quickly. Okay, and so let's see, I got to refresh my memory on what I do when I go live. I'm going to stop sharing. Oh, so here I am back full screen. And the first thing I want to show you is my compressed air tank that's sitting up on my desktop or my workshop. So, all right, so we're going to look at the volume. What's the volume? What's the volume of my compressed air tank that I use to blow things off with here in the workshop and that type of thing? What's the volume? This would be a closed system, wouldn't it? It's a closed system. There's no flow coming out of this valve. This is the compressed air supply valve. We've got a pressure gauge on it we're going to look at in the next module. But how would we determine the volume of this? I have measured it. I've done a little homework. I've measured the diameter of this tank is 10.5 inches, and I've measured the length of the tank is 23 inches. Okay. The next thing we're going to look at is something that you're quite familiar with. I guess I should get my face up here. Okay. Wow. Gallon jug. So something that this is a gallon is a measure of volume. And so everybody on the call here, everybody is familiar with what a gallon looks like. So we're going to go through some units to see how much is this in cubic feet, and how much is this, what does this look like in terms of cubic meters? So this gallon jug, we're going to do the volume calculation on that, going beyond simply stating it's 1 gallon. And then finally, I've been working on this water this afternoon. And so here is a water bottle of water. Everybody's very familiar with this. So let me read the label to you. If I can see it, it's a little dark in here for me, even though it looks bright to you. It says 500 milliliters, that's a measure of volume, and it also says 16.9 fluid ounces. So that's stated right here on the bottle. Okay, and so if this, I've just about finished my water, but if the bottle were full, it would contain half a liter, 500 milliliters of water. So let's do the math. Okay, so that's my show and tell. I showed you three things: the compressed air tank, the gallon jug, and the 500 milliliter bottle of water. So, okay, I guess I've got to share my screen now. Okay, so I'm back in PowerPoint. Okay, and then here's the math. Here's the math. And I'm going to take my glasses off so I can see better close up. So compressed air tank, here's my measurements: 10.5-inch diameter, 23 inches long. The volume is 1,992 cubic inches. So let's see, how do I go from cubic inches to cubic feet? I'm going to divide by 12, 12, and 12 to get cubic feet to cubic inches to cubic feet, because there's 12 inches in a foot. So I've got to take 1992 divided by 12, divided by 12, divided by 12 to get 1.15 cubic feet. And so this compressed air tank shown on the screen is a little bit over 1 cubic foot. I should give you a physical feel for that. How much is that in cubic meters? Cubic meters. You're going to be dealing so much with cubic meters in this class. Well, I'm going to go to this table of conversion factors, and I'm going to write down that there are 0.028317 cubic meters in 1 cubic foot. So I wrote that down, and I'm going to do the math here in Excel. And so the volume in cubic meters is 0.033 cubic meters. So what you're looking at with your eyes, both on the screen and live, okay? So you're looking at a little over 1 cubic foot and a tiny fraction, 0.033 cubic meters. All right, let's do the same thing for that gallon jug. So we've got the gallon jug. I wrote down the volume is exactly 1 gallon. 1 gallon. So now I'm going to go to my conversion factor table again and write down that 0.13368 cubic feet is equivalent to 1 gallon. So I'm going to do the math. Wow. And so I'm going to multiply 1 by 0.13368 to get that the volume you're looking at. So this gallon jug, the gallon jug of what you're seeing with your eyes, okay, is 0.134 cubic feet. And let's do the same approach for cubic meters. I'm going to look up the gallons to cubic meters in your conversion factor table to see that the volume in cubic meters of this gallon jug is a tiny number, 0.00378 cubic meters. All right. I hope this is kind of giving you a feel for what things look like. All right. Now, the water bottle. Mine's Dasani, but I've got a screenshot of Aquafina, 16.9. So let's do English units first. 16.9 fluid ounces. Let's see. I had this in my head. I didn't need to look this up in any conversion factors. I know that we should know that there's 16 ounces in 1 pint. You should know that from elementary school. You should know that there's 2 pints in a quart. You should know that there's 4 quarts in a gallon. And so if you do the math and keep your unit straight, you can see that there are 128 fluid ounces in 1 gallon without having to go to Google or anything like that. 128 fluid ounces in a gallon. And so we're going to do the math. That's our conversion factor. And so we're going to take 16.9 ounces divided by 128 to get a volume. This volume is 0.13 gallons. Okay. And also I read off the label that it was tabulated as 500 milliliters. So let's go the SI, easier route as well. Well, the volume, 500 milliliters, is 0.5 liters, isn't it? Milliliters is thousandths of a liter, so 0.5 liters. I did go, so as a memory refresher, I went to the conversion factors to see that 1 liter is 0.001 cubic meters, or 1,000 liters in 1 cubic meter. That's a lot of liters in a cubic meter, isn't it? And so the volume is 0.0005 cubic meters, or in scientific notation, 5 times 10 to the minus 4th cubic meters. Okay, a couple more slides to go, and because I don't want to drag you through 50 more PowerPoint slides in a video. It makes no sense at all, does it? I hope you have the interest in downloading this PowerPoint and breezing through the slides with just some details I have to offer for you. That's up to you, but let's look ahead. What is specific volume? Specific volume. That is an intensive property, because it's defined little v. Specific volume is defined as little v, where capital V is the total volume, is the volume of our system. This is a system, that's capital V, divided by the mass of the system. So the volume divided by the mass is equal to the specific volume, little v. And this nomenclature is very important. Little v, specific volume, okay? Big V, volume, okay? And so I said that in my little, or my big yellow text box that you've already read, hopefully. Let's look ahead to density, the definition of density for thermodynamics class. Well, the density, I hope you have a good feel for already. And that's the density rho. That's not P, that's Greek letter rho. Greek letter rho is the mass of the system divided by the volume of the system. Rho is, well, let's see, that would be kilograms per cubic meter, or pounds mass per cubic foot. Okay, that's what density is. You already have a physical feel for that, I hope. Okay, so the big conclusion is to recognize that density is the reciprocal of specific volume. So when you look at, so rho is equal to 1 over little v. Rho is 1 over little v. Okay, so we just covered volume, units of cubic meters or cubic feet. Specific volume, that's the intensive property. That would be cubic meters per kilogram, or cubic feet per pound mass. Okay. Density, pound mass per cubic foot, or kilograms per cubic meter. Okay. And so these are some key points moving ahead in your thermodynamics class. And you're at this point, you're probably saying, I think this class is going to be easy. Man, I think I've got this stuff nailed. I covered a lot of this in high school. I'm going to breeze through this class. I think that's great if you're feeling pretty confident, but I can assure you that the material gets harder and harder and harder very quickly. So here's the key points. Specific volume is the volume divided by the mass. Important to commit that to memory. Density is the reciprocal of specific volume. Rho is equal to 1 over V, and so therefore V is 1 over rho. Okay. So I've got my prompt for myself here that I'm going to end the video, but I want to encourage you to go ahead and just download this deck of PowerPoint slides so you can breeze through at your own interest. Okay, so that's it. Here, let me come back down. I think we've got it covered. I'm going to hit stop recording and do my best to get this logged and post it out to my YouTube channel.